The devices that will be software driven won't stop at the personal computer, the full screen device, or the pocket-sized device, the phone. It will really be pervasive. Your car will be software driven. We're already seeing some of that. Your TV set will simply be a screen that connects onto the internet. And so we'll no longer have this separation between the internet is where you can find lots of video and have variety, and whereas broadcast TV is where you can find the most popular videos. We'll bring the best of those together in a synthesized fashion. In fact, later, one of my colleagues will come up and demonstrate the idea of what that's going to look like. So everywhere we go, every surface will be able to turn into a display, and the interaction will be far more natural. In fact, as we get things like ink recognition and speech recognition, everywhere you go, the computer can be there, helping out, listening to what you're doing. And now, to many of you, that immediately, I'm sure, sounds exciting. To others, you think, well, what about privacy? Well, that's a very interesting software challenge, is how to design the system so that you can make guarantees to the user about how all that information that's being acquired is handled. Today, even with your cell phone, the mobile phone company actually understands not just who you call, but everywhere you go. And that's the type of information that, understanding who can access that, how it should be used, society is going to have more explicit rules and then software breakthroughs that let us handle that in the right way. So this idea of how we interface with the machine, I would say that is the next thing that's coming that people underestimate. What we broadly call natural user interface to encompass all the new interaction techniques, the touch, the speech, the vision, even robotics, which some people may think of as, well, isn't that way off in the future? The answer really, no, it's not. Robots that can drive cars, robots that can pick things up and understand visual scenes, again, it's just breakthroughs in hardware, which are definitely happening, and breakthroughs in software. And it's another case where Microsoft has a group of people who are out there working with universities, working with entrepreneurs, and saying, how can we bring our software expertise and make sure that that robotics industry gets off to a very rapid start, and you can share the different work. If somebody has a vision system or a planning system or a camera system, all of those can interconnect. In fact, as the robots evolve, you don't have to rebuild your applications. That kind of approach is exactly the same thing that happened in personal computing, and we are at a very early stage. We don't really know where robots will be used broadly, but we know that those developments will take place. We have another change in software, which is that when you have the internet there, you don't just have software running on one machine. You have the software running on multiple machines able to communicate with each other. And people often talk about this as the internet service revolution, the fact that all the software can connect. And so when you write an application, instead of having to, say, recreate the map display capability, you simply make a call to a service. Microsoft's one is called Virtual Earth, but there's others who have these as well, and get that information. And we do the hard work and make that available to any piece of software that wants to get at it. And that's driving the productivity so that you can specialize. It's the basic idea of the subroutine call that we've always had in software, but now connecting up to subroutines that are running on many different things. So the idea of connecting up across the internet, we often call that computing in the cloud. And that will eventually lead to machines that have lots of server capacity, lots of low-cost computing, low-cost storage, and that'll let us write software in an even more ambitious way, eliminate the last constraints we've had that let us do these things. Now, my optimism is actually evidenced by the kind of investments that Microsoft is making. We spend about $7 billion on research and development because we see these frontiers, we see these new opportunities. The part of that that I think has been the most exciting, as Dr. Shum was mentioning, is the investment in research. The idea of bringing the best minds together, partnering up with great universities all over the world and pursuing these new ideas. This type of research collaboration has already made a huge difference in Microsoft products. The quality of how Office works, the quality of how Windows works, the need for new security advances, which are very challenging, or privacy. It's the ideas of these researchers that are going to make sure that software evolves to meet those very demanding needs. When I talk about university partnerships, of course, I'm talking specifically about the greatest universities everywhere, and we've enjoyed a very strong relationship with the universities represented here tonight, as well as the top universities in China. So we really are thinking of this in a global way. In fact, it's amazing. China and Hong Kong, I think, will represent a very substantial percentage of the innovation that's taking place in these areas in the future. The interest of going into these subject areas is very, very high, and a lot of the most talented kids are going into these areas. Microsoft was fairly early to recognize the opportunity to be global, and in particular to have rich activities in China that would let us connect up to the nearby universities. Part of that came out of a visit I made in 1997, and so the decision to go ahead was made in 1998. And that's why this year, through a series of events, we'll kind of celebrate a decade of incredible success. When we started the lab, we thought, okay, within 4 or 5 years, they'll be doing great work. Well, literally, within a year, they were already making great contributions. And that's, as you get good people in a research lab, they attract other good people. And so that kind of magic success, breeding success, definitely took place in a very big way.